Okay, hello. So in this video, I'm doing the solutions to the midterm. I'm going to do version A in detail for the multiple choice and version B for the short answer. The other questions have almost exactly the same, maybe some small numbers change, things like that. But I'm not going to do both versions. Okay, so version A, let's do the multiple choice. And that starts here. Question 1, which way does the parabola minus 3 times x minus 2 squared plus 5 open? The key thing to keep your eye on here is the minus 3. The minus 3 means the first term after you expand it is going to be minus 3x squared, dot, dot, dot. Everything else doesn't matter. Minus 3x squared looks like that. And so the correct answer is it opens down. That question was really well done. So almost everybody got that one right. Let me make sure I'm on the right thing here. Yeah, okay. Yes, almost everybody got that one right. That was really well done. Nobody has any trouble with that. Great job. Question 2, also pretty well done. A bit higher than average. Solve e to the 2x equals 3. If e to the 2x equals 3, you can take the ln of both sides to get 2x equals the ln of 3. And if 2x equals the ln of 3, then x is the ln of 3 divided by 2, moving that 2 to the other side. So the ln of 3 divided by 2, option C. And again, if you had version B, this is all for version A. If you had version B, it will be the same exact questions, but the order of the options was different and maybe some small numbers were changed. So you can compare and see, go read those questions, see what you picked, and see what the answer was. Okay, consider the sequence 1, 4, 9, 16, 25. Is the sequence an arithmetic sequence or a geometric sequence? This is the sequence of square numbers. This is the first example we had of a sequence in class. 1 squared, 2 squared, 3 squared, growing by squares. If you look at the differences, 4 minus 1 is 3, 9 minus 4 is 5, so it goes plus 3 plus 5. Already, it cannot be an arithmetic sequence. The things you add to get from one number to the next number are not always the same. They are changing. It is not an arithmetic sequence. If it was going to be a geometric sequence, the ratios would be the same. So the ratio of the first number to the second number, 4 divided by 1, is 4. The ratio of the third number to the second number is 9 divided by 4. That's like closer to 2. So the ratios are also not the same. So because the differences are not the same and the ratios are not the same, it is neither arithmetic or geometric. That one was pretty well done. Question 4. Question 4 was not very well done. Lots of people struggled with question 4. It was a hard one, I guess. There was supposed to be one that was similar to it on the practice midterm, but I think maybe, I don't know, the message didn't come across. In any case, question 4 is all about the sequence of the form b to the n. And in your notes, we learned that b to the n, the limit of the sequence b to the n, this depends on what n is. It depends on what b is. If b is equal to 1, if b equals 1, the limit is 1. If b is bigger than 1, like a number like 2 or 3 or 5 in this case, the limit is infinity. The limit is infinity if b is bigger than 1. And if absolute value of b is less than 1, so this includes all the negative numbers between -1 and 1, the limit is 0. And last but not least, and this is what the question was actually asking about, the limit does not exist but is not infinity when b is less than -1. And it is exactly this branch that we're looking for that does not exist when b is less than -1. If you didn't have this written on your formula sheet, I think this was a very hard question. So maybe that's why people didn't get it right so much. The correct answer, we're looking for the situation where the base is less than -1, and that is option B, -5 to the n. And this is the situation where the numbers get bigger and bigger, but alternate between positive and negative. Option B, -5 to the n. That's correct. Okay. Question 5 was another one where I tried really hard in class to go over it a bunch of times, this idea of type 0 over 0, but again, people did not do very well on the exam. I think this was the lowest one of all the multiple choice, just a little lower than question 4. And this is basically saying the limit of the a-n's is 0, the limit of the b-n's is 0. Based on this information, what is always true about limit of a-n over b-n? And this is essentially asking you, when you have a type 0 over 0, this is definitely type 0 over 0, what is always true? What is always true? So it is definitely a type 0 over 0. The limit of the a's are 0. The limit of the b's are 0. And what is always true? So a lot of people chose it does not exist. They said if you have a type 0 over 0, it automatically does not exist. That is wrong. Sometimes when it's a type 0 over 0, the limit does exist. Sometimes it does not exist. So it does not exist is wrong. Another common choice was it equals 1. I think people thought 0 divided by 0, they cancel out, you get 1. It does not equal 1. It does not equal 1. 0 over 0 is not 1. Another common choice was it equals 0 over 0. 0 over 0 is not a number. Nothing can ever be equal to 0 over 0, full stop. Nothing is ever equal to 0 over 0. Some things are type 0 over 0, but equals 0 over 0 is also not right. I think it equals 0 was not very common. Some people chose that, but the correct answer is, of course, none of these always happen. If you have a type 0 over 0, anything can happen. The limit could be 8, the limit could be infinity, the limit could be negative a million, the limit could be anything. When you have a type 0 over 0, the lesson is you need to investigate and be prepared that anything can happen. That's what I was trying to get by with this question. I think none of these are always true. It was like the third most common answer chosen in this one. So this one people really struggled with. And there was a corresponding short answer question with a similar kind of issue people had. When we get to the short answer, I'll talk about this one. Okay, question 6. In the end, people did very well on question 6. It was one of these compound interest ones, and it was about continuous compound interest. Continuous compound interest. When you have continuous compound interest, you definitely need to use an exponential, an e, so that one's definitely wrong. And you want the amount of time, the 3 years, to be in the exponent. So that is suggesting it should be 3. But actually, in the question, it said the interest gained, just the interest gained, and that was in bold and italics because I made the exam the same time that I told you guys in class that I made a mistake in one of the videos with the interest gained versus the total amount in the bank account. So what I was intending with this question was that everyone go, ah ha ha, Professor Nika put on the question that he talked about in class. The answer is none of these. The amount of interest gained is the formula 200 e to the 0.05 times 3 minus 200. That is the formula of the interest gained. This is the bank account balance. Bank balance. And then you have to subtract the original amount to get just the interest gained. So if you want just the interest gained, the correct answer is none of these. However, I think it wasn't a fair question. So a lot of people didn't get that. Only very few people got none of these. So I ended up marking it that if you selected this, it was also correct. So I counted both C and D correct. And I am emailing everybody who selected option D. Those people get a bonus point. If you chose option D, you got an extra point. You got the 1 point for getting it right, and you got an extra bonus point on your whole midterm for catching the fun little interest gained trick. Okay, so that's that one. So actually that one in the end, because I accepted C or D, was really well done. Almost everybody got that one right. Okay, option 7, also not super well done. A little bit below the average of all the other questions. It was about limits. And in this situation, we are told the limit from the left is 3. The limit from the right is also 3. But the value of the function is 5. And what happens when the limit from the left is 3 and the limit from the right is 3 and the value of the function is 5? You have two options. It could be continuous or the limit could exist. And the first thing is to just separate these two questions out in your mind. One question has nothing to do with the other question. Just figure out if each one is true or false independently. So first things first, does the limit exist? The answer is yes. This was one of the rules for limits. If the limit from the left and the limit from the right are equal, then the limit exists and is equal to that value. So not only does the limit exist, but the limit is actually 3. And that's because the value of the left and the right limit are exactly the same. So the limit is 3. So 2 is definitely true. Let's look at point 1 now. Is the function continuous at x equals 1? And the answer to this is no. Why is the function not continuous? Because the value of the function is not equal to the limit. So the value equals 5, the value equals 5, but the limit equals 3. So the value is 5, but the limit is 3. If the value and the limit are not equal, the function is not continuous. That is exactly what it means for it to be continuous. So 1 is false, 2 is true, and that means the correct answer is C. Only 2 is true. This one was, just a little bit below average. I guess pretty average for the question. The last 4 were almost all exactly average. So people, like around 70% of people got them right in all 4 of these questions. This was checking to see if you could do limits visually from a graph. I guess the first easiest one is what is the value of the function f of 4? And that is this dot over here. F of 4 is this dot. and that is 0. The value is 0. The limit as x goes to 4 plus, we're talking about numbers a little bit bigger than 4. That is talking about this limit approaching in a little bit bigger than 4. No, I lied. A bit bigger than 4 means down here. So in option B, in version B of the exam, is all at 5 instead of at 4, but same idea. So this question 8, is talking about this. You're approaching 4, but you're getting x values that are getting smaller and smaller towards 4. The value of the limit is exactly what they're approaching. The y values are approaching 2, and it's that height 2. So question 8 is that. Question 9, the limit from the left is talking about these y values that go up, up, up like this. Those y values are approaching 0. Those y values are approaching 0. And you can see that the y values here, as the x values get close to 4, but are a little bit less than 4, the y values approach 0. Okay. All right, so that was question 9, is that purple stuff. Question 10, you cannot read from the graph directly. You have to do the left and the right limit separately. It was the same idea as this point number 2 up here. The limit from the left and the limit from the right in this case are not equal. One of them is 2, one of them is 0, and therefore the correct answer is that the limit does not exist. Does not exist because they are not equal. And that is it for the multiple choice. So overall, pretty well done. Around, I think, a little bit less than 70% average. Yeah, something like that. Overall on this multiple choice. Yeah, and people did, pretty well on these. And I think they struggled with these like logic-y ones of the 0 over 0 really threw people for a loop, and this b to the n one. I guess both of them involve, this like idea of a limit does not existing. Maybe that was part of the problem. Okay, that's it for version A of the multiple choice. Version B of the multiple choice, you're gonna have to translate a little bit what I did. But let's move on to the short answer. And for the short answer, I'm gonna do version B to make things nice for the version B people, that they at least have some questions fully done here. Question 1, really well done. Everybody got full marks on question 1, 100% right. Let me change my information here. Okay, question 2. Question 2, I meant for it to be a complete giveaway problem, and I was hoping that everybody on the exam would start off really strong with a full mark on question 1 and question 2. This is, if you know what these sums mean, if you know what this sigma means, this question is like the easiest question possible. Let's instead of figuring out what is it, let's figure out what does it mean. What does the sum from I equals 3 to 5 of I mean? What does it mean? It means we start our variable I at 3 and we end at 5. So we're gonna go 3, 4, 5, and we're adding up I. So it means we're doing the sequence 3, 4, 5. That's what 3 to 5 means. And because it's just I, and I is the variable, we're literally just adding them up. 3 plus 4 plus 5. So this question is literally asking you, what is 3 plus 4 plus 5? And it's hidden behind a layer of notation. That's why it was a question. I wouldn't ask a question 3 plus 4 plus 5. But I would ask, please find the sum. If you can unpackage the sum as 3 plus 4 plus 5, then of course it's a snap. 3 plus 4 plus 5 is 12. I think the other version of the exam had 2 plus 3 plus 4. But in any case, it's asking you to add up 3 one-digit numbers. That's what it means. I saw all sorts of really wild solutions to this problem using the formulas for the geometric sum and all sorts of like all over the place things. I think part of it was people tried to like overly memorize the practice midterm, which led them wrong. But this really shows me that the people who got this wrong don't know what this sum notation means. So I think it's actually a very good question, even though the average on this one was less than 50%. So it was supposed to be a giveaway. I thought everybody would get 100%, but it was actually the worst done problem on the whole short answer was this question 2. And people only like half the people got it right. Okay, question 3 was really well done. You find the slope. This was the exact points I think on midterm 1. The slope in this case is, what is it? 10 minus 2 divided by 9 minus 7, which is 8 divided by 2, which is 4. So the slope is 4. So you're going to get a y equals 4. And then you're going to put in x minus some x value that is on the line. So once you have the slope of 4, you can use the point slope formula. And I'm going to do x minus the point on the line I'm going to choose is 7. And the y value I'm going to choose is 2. 2. So I'm going to do plus 2. So that is a perfectly good answer, 4 times x minus 7 plus 2. You could write this in any form you wanted, and we would have given you the mark. You should check and make sure, if you wrote it in some weird way, make sure you got the mark if you got the same answer as that. And now I'm embarrassed if it's wrong. Let me just make sure that's right. I think it's right. Okay, good. So that was really well done. I think that was the best done problem on the whole. Short answer. Okay. Question 4. A population of bacteria is growing according to an exponential growth model, a e to the kt. The population initially has 100 bacteria, and 5 hours later, it's at 200 bacteria. Find A and K. So the first thing is that A is just the initial population. This is the initial population. And you can see that in the formula by plugging in t equals 0 here if you want. But A is the initial population, so it's just 100. So that was, again, supposed to be very straightforward. Again, really well done here for the option A. If you didn't get option A, some people get bamboozled by the difference between A and A0. So some people screwed that up. But almost everybody got this one right for A0. For A equals 100 at time 0. Finding K, again, was also really well done. And it's a matter of solving 5 hours later, you're at 200 bacteria. So if 5 hours later, you're at 200 bacteria, that means f of 5 equals 200. But what is f of 5? F of 5 is 100 times e to the k times 5. So you have this equation, 100 e to the k times 5 equals 200. In other words, e to the k times 5 equals 2. And taking the log of both sides, k times 5 equals 2. Ln 2, rather. Taking the ln of both sides, ln 2. And therefore, k equals 1/5 of the ln of 2. So ln of 2 divided by 5. Some people wrote this out in a really nice way. They wrote 1/5 ln of 200 divided by 100 to showcase where all the ingredients of the problem are from. 200 bacteria at the final time, 100 at the initial time. It took 5 hours. That's K. That works perfectly well. This was actually really well done. This was one of the better done questions on the exam. Okay, next up was question 5. Question 5 was only worth 1 mark and was not super well done. A little bit worse than average. So I think right around 60% of people got this one right. And again, this is the same kind of deal as that exponential thing we just did, but it's solving an equation for a logarithm rather than exponential. So the way you do it is you take the exponent of both sides to undo a log. How do you undo a log 2? Take 2 to the power both sides. So if you take 2 to the power on the left-hand side, you have 2 to the log 2 of 3x minus 1. And on the other side, you have 2 to the 3. And the 2 to the power and the log undo each other, 3x minus 1. So you end up with this equation, 3x minus 1 equals 2 cubed, and 2 cubed is 8. 3x minus 1 equals 2. In other words, 3x equals 9. And if 3x equals 9, then x equals 3. So x equals 3 is the answer. And again, there's multiple ways you can kind of undo this thing, but you have to somehow, at the end of the day, undo the log. I saw a lot of people who applied log to both sides. So they wrote log 2. Let me do it in a different color so you know it's not right. They wrote stuff like the log 2 of 3x minus 1 equals the log 2 of 3. That was their first step. So they applied log 2 of 3 just to the right-hand side, and then had that, and then they went 3x minus 1 equals 3, and then x equals, I guess, 4/3 or something. So if you did that, it's not right because you can't just apply a log for nothing. If you want to do it this way, you totally can, but you have to convert 3 is the log base 2 of what? 3 is the log base 2 of 8, right? So if you want to add in a log 2 like that, you got to make sure it's the right thing. And 3 is the log base 2 of 8. That does work. And then you can get the equation that I got, which was 3x minus 1 equals 8, and it will be perfectly fine. Let me just check something here. Okay, good. So that one was 3. I think on the other version of the exam, very similar with base 3 instead of base 2. Okay, and that brings us to question 6. Question 6.1, the number of terms. This was about average for the exam. The number of terms, and it's kind of, the numbers here are kind of supposed to be set up easily to see what's going on. You're always adding 3 to each term. So you're doing plus 3, plus 3, plus 3. How many times do you have to add on plus 3 starting at 1 to get to 3001? Well, if you add on 1,000 times, then you'll have added on 3,000, which is what is going on here. So you can puzzle it out this way and figure it out. The other simple way to do it is to just write down everything you know. So A equals 1, D equals 3. The common difference is 3 in this arithmetic series. And if A equals 1 and D equals 3, what is the number of terms? Well, we know that the last term, 3001, is equal to A plus n minus 1 times D. And in this situation, we know that A equals 1 and D equals 3. And we can solve for n. Let's subtract 1 from both sides. 3000 equals n minus 1 times 3. And therefore, 1000 equals n minus 1. And if 1000 equals n minus 1, then n equals 1001. So that is the correct answer over here. Another way to do it is the simple way I said before. We have to add on 3 1,000 times. And so if we add on 3 1,000 times, there's 1,000 terms that come after the 1. And with the first term 1, that's 1001. So this one was pretty average. People got very confused by the sum. So the sum was really poorly done and was almost as badly done as question 2 on the exam. The sum, the way I would do it, and this is the way I tried to show in the videos and in class and everything like that, do the average of the first and the last term times the number of terms. So if you had written 1001 times 3001 plus 1 divided by 2, that is perfectly correct. That's the average of the first and last term times the number of terms. If you want to simplify it a bit more, it's 1001 times 1501, right? 3001 plus 1, 3002 divided by 2, 1501. And if you write that out, it's 1501 plus 1501, like this. So you get, doing this in my head quickly, of course you guys had calculators on the exam, 2501. That should be the answer. Yeah, 1,000,000, 1.5 million, 2,501. So a lot of people got bamboozled here by equations. In particular, I saw a lot of people using the geometric series equation. Again, probably they copied, I think, from the practice exam that had the same exact question, but with a geometric series instead of an arithmetic series. So that one was not super well done. I thought, again, that would be not too hard, especially given the number of terms was pretty well done. I thought that would be easier, but I guess not. Okay, question 7 on the next page. This one was pretty well done for the most part. I think everybody who knew what they were supposed to do nailed it. And the most common mistake, if you avoided this mistake, I think you did quite well, is to notice that this is type 0 over 0. And a lot of people said type 0 over 0 and therefore does not exist. If you wrote type 0 over 0 and you said therefore it does not exist, then you got 0 marks on this question. And that's not great because it was 2 marks. What did you actually have to do? So this is totally wrong. What you should do is you should say type 0 over 0, let's try to do something. And the something you should do in this case is factor. You factor top. A lot of people, again, I think got excited by the practice midterm and tried to do multiplying by the conjugate. This thing technically doesn't have a conjugate, but they tried to multiply by things like x plus 2 over x plus 2. And that is a good try to do something. I think if you tried something like that, that was reasonable. I think you got 1 out of 2 for just like trying something. But to really do it right, you got to factor the top. The top here is x minus 2 times x plus 1 over x minus 2. And you're doing the limit as x goes to 2. And the nice thing about this is the x minus 2's cancel out. So you end up with the limit as x goes to 2 of just x plus 1. And now you can just plug in to get 2 plus 1, which is 3. So the limit is 3. And that is how you should have done it. Okay, my face is covering up the 3. How do I make my face not cover up the 3? I go like this. There's the limit is 3. Okay. Okay, so as long as you avoided this pitfall of doing type 0 over 0, therefore does not exist, or something like that, and you tried something, you got at least 1, or you should have, I think as long as it looked like something reasonable that could lead to the right answer, maybe in a different problem. And for full marks, you had to factor and then do the just plug in. Okay, so that one was, question 7 was right around the average. Okay, question 8 was quite a bit below average, like a little bit, not a ton. But I think what happened here is people tried to do some kind of like hack to like get to the answer without actually doing the work. And so what we wanted to see here was the formula for the principal. So if you have to write down the formula, which is 1 plus r over m to the power mt, that has to be somewhere on your page. And in this situation, M is 12 because it is monthly. So M was 12. 12. And R is given to you is 0.24. Okay, so you have this equation. This is telling you how much is in your bank account at time t. And you want to solve for the amount being twice the initial amount. So you can put in this equals 2, or you could have said the initial amount is 100 and we want to get to 200. But in any case, you're going to have this equation, and then you have to solve. So how do you solve for it? Again, you have to do those log skills. Take the log of both sides, and you get this 12t jumps down times the log of 1 plus 0.24 divided by 12. I tried to make the numbers nice. 0.24 divided by 12 is 0.02. So you get the equation ln of 2 equals 12t times the ln of 1.02. And therefore, t is equal to the ln of 1.02 divided by, it's the ln 2 divided by the other one. The ln 2 divided by 12 times the ln of 1.02. So that is the correct answer. If you plug it in your calculator, I don't remember exactly what it was. You can plug it in your calculator and see. So a lot of people tried to do a trick of like just involving the ln 2 and like skipping the actual work. Some people confused compounded monthly with a continuous exponential growth rate. So I think that's why a lot of people, the average on this question was a little bit lower than the average overall. And the other thing I will say about this question is somebody, after I wrote the exam, somebody asked this exact question on CampusWire. And that is because this question was taken directly from the homework problems. And on CampusWire, there's a full solution of this formula appears. So people who like prepared well for this, I think absolutely nailed this one. But people who didn't really take the time to like go through these problems got a little stuck. Okay. Question 9 was right around average. Question 9 was right around average. This was a limit with two sides, and you have to know to split it up into two parts. So there's the part over there and the part over there. Of course, when you're doing limits, what happens at x equals 3? At x equals 3, this is irrelevant. So some people got bamboozled by that. And what happens at x equals 3 completely doesn't matter for a limit. For a limit, what happens at the point is completely irrelevant. The only thing that matter are x squared plus 1 and 4x minus 2. And those matter for the left and the right limits respectively. So you do the limit as x goes to 3 minus of f of x. That is this stuff less than 3. So that is x squared plus 1, just like we did in class. And this one you can just plug in. Just plug in. And if you just plug in, you get 3 squared plus 1, also known as 10. What about the limit on the other side? The limit on the other side is the limit as x goes to 3 plus of f of x. That is the limit as x goes to 3 plus of 4x minus 2. And once again, you can just plug in. And when you plug in, you get 4 times 3 minus 2, 12 minus 2, also known as 10. And so that's what you had to do for this question. It was really asking you, please do the limit from the left and please do the limit from the right. And once you do that, you realize they're both 10. And if they're both 10, then by the result that says if the two limits are equal, then that is the final answer. Then therefore, the limit exists and is equal also to 10. So that was for 3 marks. This one was worth the most out of everything on the exam. I think the way it was kind of split up was 1 mark for the left limit, 1 mark for the right limit, and 1 mark for putting it all together over here. So maybe you could say, because left limit equals right limit, therefore limit as x goes to 3 of f of x equals 10. 2. Okay. And I think a lot of people got 2 out of 3 who did these things, but then got confused by the value of 5 or stuff like that. So a lot of part marks on this one, which, yeah, okay, it was like a little bit less than average. Okay. Okay, last one, question 10. Leonard is working on this limit. Leonard has the following logical reasoning. He did the limit as x goes to 0 plus of 1 over x equals infinity. This is perfectly correct. The limit as x goes to 0 plus of 1 over x squared is also plus infinity. And both of these are the idea of dividing by a very small number is going to be a really big number. And because x is positive here, 0 plus, everything is always positive. There are no negative numbers. So again, I saw a lot of people who picked number 2, maybe because that was the right answer on the practice midterm was number 2. But Number 2, I think, is the one that could least likely be right because x squared is making things positive. So maybe you could argue, oh, number 1 is wrong because x could be negative. But number 2 is definitely correct. They're both correct. The right answer was number 3. And actually identifying which of these 3 is the wrong one was pretty well done. So I think like 75% of the people got it right. The difference, that is where the problem is. This line is wrong. And why is it wrong? Here is the thing I think one student wrote that got him full marks on the explanation. You can write infinity is not a number. This would receive full marks in the way we graded it. And the reason is because Leonard tried to do infinity minus infinity equals 0, right? So he's trying to apply the limit law, and he's doing the limit of one thing minus the limit of the other thing. But by the first 2 things he said, those limits are both infinity. So Leonard is doing infinity minus infinity equals 0, but infinity is not a number. Doesn't work. Doesn't work. And there's a million other ways you could have explained this idea. You could have said the limit law doesn't apply. You could have said you can't subtract infinity. You could have said, I don't know, subtracting infinity is not allowed. There's a lot of different ways to describe it. And again, you did not need to evaluate the limit or understand what the limit is. You just needed to identify that the difference limit law does not apply for infinity. Oh, another way to say it is if you said limits that are infinity do not exist, right? From 1 and 2, the limits don't exist, and therefore the limit law doesn't apply. That would also be fine. So that's what we were going for this one. And this one was kind of like medium done, definitely below average, but not by a super amount. So I think people struggled with that. And I guess part of the problem was anyone who got the first part wrong automatically got the explanation wrong because they tried to explain something that was definitely not true. Okay, and that is it for midterm 2, which overall was done okay.